Standard EE.7a is about solving equations and specifically determining the number of solutions to an equation. Problem 1 asks if this equation has one, no solution, or infinitely many solutions. So we're going to go through and simplify and then solve this equation. First, we're going to look for distributive property. 2 will distribute to each term in the parenthesis, which is multiplied. 2 times 3x is 6x. 2 times negative 1 is negative 2. On the right side of the equation, we have 6 times 2 is 12, and then 6 times x is positive 6x. At this point, we don't have any more simplifying we can do because we don't have any like terms on the same side of the equal sign. We do have a term that's got a variable on both sides of this equation. We have this term 6x. And at that point, I can actually tell that I have the same x terms and different constants. So these will have no solution, but I could prove it. I'm going to get rid of this 6x by subtracting 6x. What I do to one side, I must do the same to the other side. And in both cases, since we started with 6x on both sides, they both cancel out. And we get negative 2 is equal to 12. Well, when you get to a number equal a number, it's either true or false. In this case, this is false. So this means we have no solution. Now we could say earlier that we had at this point, that we had the same x term, different constants. And that indicates there's no solution to this equation. Number 2 is a word problem. Jane buys several shirts for $27.50 each and a pair of shorts for $19. Yuki shops at a different store and buys the same number of shirts for $24 each, plus a pair of shorts for $33. Is there a situation in which they pay the same amount for their purchases? So we want to know where they pay the same amount for their purchases. So let's just start with representing Jane. Jane is shopping, and she has found these shirts for $27.50 each, so X number of shirts, and buys one pair of shorts for $19. That's a one-time amount. Yuki, she is shopping at a different store, and she buys the same number of shirts for $24 each. So 24 times X, whatever that number of shirts is, plus a pair of shorts for $33. We want to know when they pay the same amount. So when Y, the amount they're paying, is equal. So this is where Y is equal to Y. And this is actually a systems of equations problem, but we can use our equation reasoning for it. And we get this. We get 2750. I'm going to shorten it to 27.5x plus 19 is equal to 24x plus 33. So I'm just going to solve this and see if there's an x value that's true for this. So we can't do any simplifying. We're going to subtract 24x from both sides to get that variable term by itself. And I get this. I get 3.5x plus 19 is equal to 33. Now we have just a little two-step equation to solve. So let's subtract 19 from both sides. We get that 3.5x is equal to 14. Divide both sides by 3.5. I get that x is 4. And we did find a solution. There was one solution. And it is where there are 4 shirts each. That is the case where they could pay the same amount for their purchases while buying the same number of shirts for each. Number 12, without solving, determine whether this equation has one solution, no solution, or infinitely many solutions. So it says this without solving, but we could simplify it. We know that this left of this parenthesis is a negative 1. If you don't see the number beside that sign to the right, to the right of that minus sign, then it's an invisible 1. So we get 3x and then we're going to distribute negative 1 times x is negative x. Negative 1 times positive 1 is negative 1, and this equals 2 minus x. I'm going to further simplify and say, well, I have 3 minus 1 on the left side, which is 2. I'm going to bring down that minus x equal 2 minus x. Now, I have not fully solved for x, but at this point, the left and right side are the same. This is a true statement. So I can tell at this point that there are infinitely many solutions because the left and right side have the same, are exactly the same. They look exactly the same. Standard 8.EE.7b is focused solely on solving equations. Let's start with number 3. We're going to solve this equation. Let's simplify both sides of this equation. On the left side, we can do distributive property. 4/5 times x is 4/5 x. 4/5 times 2 is 8/5, or you might use your calculator and get 1 3/5. On the right side, there's no distributive property, but there are like terms. 4x minus x that we can combine to get 3x, and then we'll just bring down that minus 5. Now at this point, we have an x term on both sides. So I'm going to get rid of one of those. I'm going to get rid of the smaller one, 4/5 x. I prefer to get rid of the smaller one, but you could choose either. And the result is 1 3/5 is equal to 2 1/5 x minus 5. Now it's just a two-step equation. I want this term, 2 1/5 x by itself, so I'm going to add 5 to both sides. The result is 6 3/5 is equal to 2 1/5 x. And all we have to do is divide here. When we divide both sides by 2 1/5, we get that x is 3. Answer choice A. Number 8, steps are shown to solve this equation. Identify the error that was made and what is the correct solution. So we start with this line, which is just copying the problem down. And then what we would typically do is the distributive property, and we would say, okay, negative 6 times 1 is negative 6. Negative 6 times negative x is positive 6x. So that would be where the error occurs. Now to get the correct solution, I would just rewrite the problem and start over. So we do distributive property. We get negative 6 plus 6x and bring down the rest of that left side. We'll go ahead and bring down the right side as well right now. And we can combine like terms. On the left side, 6x plus 3x is 9x. We'll bring down the minus 6. And on the right side, 3 plus 5 is 8. So we'll bring down 3x and write down that plus 8. At this point, we've now got an equation with a variable term on both sides. So I'm going to choose to get rid of one of those variable terms. I like to get rid of the smaller one. So I'm going to subtract 3x from both sides. And we get that 6x minus 6 is equal to 8. Now it's just a two-step equation. I'm going to box in the x term and add 6 to get rid of it on both sides. And the result is 6x equals 14. And last, we'll divide both sides by 6 to get that x is 14/6, which we could write as 7/3, or we could write, go in our calculator, we go to it and get 2 1/3. And we're finished. Number 11, Dave has $70 saved and earns $20 each month in allowance. Terry has $110 saved and earns $16 a month in allowance. If they both save their entire allowances, how long will it take before Dave and Terry have saved the same amount of money? So we want to know when they have the same amount of money. We are told the amount that they have already saved, and then there's an amount that they add every month. So I'm going to go ahead and start with Dave. I'm going to write it into y equal mx plus b. He has already saved $70, that's b, that's an initial value, and he earns $20 each month. That word each tells us it's repeated, so that's m, the slope. So y equal 20x plus 70. Then we're going to look over here at Terry. We're going to plug into y equal mx plus b. Terry has $110 saved, that's B, and earns $16 a month. That's a rate of change, it's repeated, it's m. So we plug in and we get y equal 16x plus 110. When will they have the same amount? When will their y's be the same, is what that is saying. So when 20x plus 70, there we go, when 20x plus 70 is equal to 16x plus 110. So let's just solve this. Let's subtract 16x from both sides of this equation. The result is 4x plus 70 equals 110. And it is now just a two-step equation to solve for x. So let's box in x and subtract 70 from both sides. The result is 4x is equal to 40. And dividing both sides by 4, we get that x is 10. And so x was talking about the amount of months, because we saw it was $20 per month, $16 per month. So both of those x's were the number of months. And it's asking, how long will it take? Well, it will take 10 months.